Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to go over how to divide a line segment into two parts with any proportion. I know that most of you already learned in school that, for example, if I have a straight line, it doesn't matter what dimension, meaning 1D or 2D or 3D, it doesn't matter. So let's say you have a line here, and just let's take a very simple case. Oh, it's a new pen, so I have to take this out. And let's say this point just on the x-axis, okay? So very simple. And let's say this point is 4, and this point is whatever, 16. You learned in school, whether it's a 1D or 2D, how to find the coordinates of the midpoint. And it's called the midpoint formula or the midpoint equation. And I always wondered, what's so special about the midpoint? I mean, sometimes I may need to have like a point that divides that distance into 1 to 3, like 1/4 and 3/4. Someone will say, okay, no big deal. I can get the midpoint, and then I get the midpoint of that midpoint. It's like, yeah, but why don't you do it once and for all? Let's first write the equation of the point. Oh my God, these are new pens. I had to clear this. X, they told you, if you want to find X, take x1, which is the first point, plus x2, and divide by 2, and you feel like you conquered the world, you know everything. But is it really true that we add these 2 points and divide them by 2? No. What? No, that's how we do it, and it's correct. I know it's correct, but that's not the basic of it. There are two ways to find that point mathematically. Is to say, I want a point that divide this distance into the ratio 1 to 1. Or you can say, I want to take this line segment and take half of it here and half of it there. Both will give you the same result. But see how it works. I'm going to say, I'm going to take the first point, which is 4, and multiply it by the furthest ratio. It's 1 to 1. In this case, they are the same. But if they are different, I'm going to multiply the 4 by the 1 and multiply the 16 by the other one, and then divide by the sum of these two, which is 1 plus 1. Of course, you will get the same result, which is 4 plus 16 is 20. Yeah, 4 plus 16 is 20. And then you divide by 2. Yeah, 1 plus 1 is 2. So you will get 10. Okay? Or you could have used that if you have just a ratio that add up to 1. So the sum of these fractions is 1. So you multiply 4 by the second fraction and the 16 by the first fraction. In that case, you don't need to divide by anything because the sum will always be 1, right? Half and half is 1. So you can say over 1, but it's the same. You still get 10. They say, okay, so why do I do it this way if I can simply add them and divide by 2? Yes, I'll tell you why. I'm going to take the same line, 4 and 16. And I want to find a point here such that this is 1/3 of the line segment, not 1/2, and this is 2/3. How would you do it using your equation? There is no way. Sorry to burst your bubble. You don't have a way to do it. Or you can say, I want them to be in the ratio 1 to 2, like we said here, 1 to 1, 1 to 2. See how easily I can find that x. Let's call it x1 since we call that x. Okay, so x1 would be the first point times the second proportion plus the second point times the first proportion over the sum of the proportions. So I get 8 plus 16 over 3. 24 over 3, it's 8. So if this point is 8, we said that point was 10, right? You see the difference here is 6 and here is 6, so it's half. Here the distance is 4 and here it's 8, so that's half of that. Very simple. So why do we insist on teaching the midpoint formula? It's any ratio. It's not just the midpoint. Again, if I don't want to divide by anything, I could have said x1 equals 4 times 2/3 plus 16 times 1/3. And of course, you will get the same result. You get 8/3 plus 16/3, which is exactly this thing. And then you add 24/3, which is 8. You can do that for a line in 2D that has an x and a y. You can do that in line in 3D that has x, y, z and x, y, z. In hyper dimensions, even though you cannot visualize it and you say, I have 7 dimensions. Yeah, you can find the midpoint in 7 dimensions or any other number of dimensions. Let's take another example, and then I will show you an extension to that, small extension to that. Suppose, let's pick 2 numbers that would make sense according I want to. Okay, so I'm going to pick a point here, A, and a point B. And let's say I want this to be -3 and 5, just any numbers. And I want this to be 11 and 26. Okay? And I want you to give me a point here that divides this line segment into the following ratio, 5 to 2. What would be the coordinates of this point that I'm going to call x and y? Notice that since they add up to 7, I can say, or I want this to be 5/7 of the total distance, and this is 2/7 of the total distance. It's the same thing. Like here, 1 plus 1 was 2, so I said 1/2 and 1/2. 1 plus 2 is 3, so I said 1/3 and 2/3. It's just very simple, right? So in this case, to calculate the x, I'm going to take the first x, which is -3, and multiply it by the second proportion, and then take the second x and multiply it by the first proportion, and then divide by 5 plus 2. So I get -6 plus 55 divided by 7 equals 49/7 equals 7. So the first coordinate is 7. See how easy it is? I pick the numbers far away by a multiple of 7, so we get an integer, but you can get a fractional point. It doesn't matter. The y, I'm going to take the first y and multiply it by the second ratio, and take the second y and multiply it by the first ratio, and then divide by 5 plus 2. So I get 10 plus 130 over 7 equals 140 over 7 equals 20. And you can do whatever you want. Any ratio, it doesn't matter. Any proportion, it doesn't matter. One last extension. Suppose, and here, this one is, I think you would like it. It's very important. Suppose I have a line here. And this line AB This point, for example, is 2 and 9. And this point, let's say, what do I want to do it? Well, it doesn't matter. We can pick any point. Uh, 12 and 24, whatever. It really doesn't matter. But I don't want to divide it like that. I wanted to extend it. What? Yeah, I want to extend it either this way or that way. It doesn't matter. But since we have more uh, space here, I'm going to extend it here to a point C, X and Y, such that the ratio from A to C is 3/10 of the total distance. Oh my God, no, that's too tough. I don't know how to do it. It's like, that's so complicated. Can I calculate that distance and then find the equation of this line, extend it 3/10? And I don't know. What do you think? Think about it. When I was here, I said a ratio 1 to 1. When I come here, it's 1 to 2, 1 to 3, 1 to 10. Oops, 0 to 1. Meaning if I'm here, I will not move from here, right? Because this point is already picked. But what if I am here? That distance would be -3. Notice, if I'm here, I would say, for example, 9 to 1, 5 to 5, 1 to 9, 0 to 10. But when I go to the left, it becomes -3. I want this ratio as an absolute value to be 3 to 10. Meaning that distance, because I'm moved, usually I move to the right from A and to the left from B. But here I moved to the left for both. So this ratio would be -3 to +13. Why? Because going from B, you go to 10 and 3 more. So that's positive. But the A should move in this direction. It moved, however, to the opposite. So I get -3 to 13. So the ratio, instead of being 1 to 2, I'm sorry, 5 to 2, now it becomes -3 to 13. Let's see if that makes sense. I'm going to take the coordinate of the first point, which is 2, multiply it by 13, and take the coordinate of the second point, which is 12, and multiply it by -3, which is the first thing. And then I divide by the sum, which is 10. So I will get 26 minus 36 over 10 equals -10 over 10 equals -1. So the x here is -1. Does that make sense? Of course. In fact, I give you the 10 to make it easy, but you see, this distance is 10, so 3/10 of 10 is 3. So I move 3 to the left. The 2 minus 3 is -1. If I want to find the y, I can say y equals the first y times the second proportion plus the second y times the first proportion divided by 10. Again, because I made them 3 to 13. If these didn't add up to 10, they added up to 12, I will divide by 12. I just picked an easy thing, so the math wouldn't be tough. 117 minus 72 over 10 equals 45 over 10 equals 4.5. No, I'm sorry. Yeah, it equals 4.5. Notice that from 4.5 to 9, I go up 4.5. From 9 to 24, you go up 15. So what is the ratio of that? If you divide by 1.5 both, you get 4.5 over 1.5 is 3, And 15 over 1.5 is 10. Yes, it's 3 to 10 as we want. But we write it negative because we are on this side. If we were in that side, the A would have been 13 and the B would be negative 3. Why negative 3 if I'm moving to the right? No, B moves to the left and A moves to the right. So if B moves to the right, it becomes negative proportion. And now if I give you any line in 2D or 3D, if I have X, Y, Z, I give you the coordinates of the three, and I tell you divide them to the ratio 3 to 4, you know how to do it, right? And it's so easy. I hope that was a light session. You learned from it. If you have any questions or if you see something that doesn't make sense to you, please let me know by dropping me a line in the comment section. How many times should I say comment session? I don't know what that is, but anyway, I'm an old man. I keep saying crazy stuff, but anyway, so I wish you all the best. And again, if you have a question, let me know, and I will try to get back to you as soon as I can. Otherwise, hope to see you soon. Bye.